Hi, Electron John here, and today I want to talk about something that I get a ton of phone calls, emails, text messages on all the time. There's a big misconception of what it takes to actually service a high voltage battery. Now, we've said in a lot of our previous videos before that servicing a high voltage battery is very important. Batteries become out of balance. You can watch any of the other videos that we've shot in the past to understand all about high voltage batteries. But when batteries become out of balance, traditionally what ends up happening is people lose mileage between charges. So if it had 300 miles of range at one point, now 6-8 months down the road, you fully charge that battery and you maybe have 270 miles of range. Plus, when the battery's out of balance, it actually discharges at a faster rate of speed. So we all know, and we've talked about this in some of our other videos, about balancing a battery, but there's more to it when you actually charge your customers to perform this battery service. So I wanted to kind of just touch on that subject a little bit. Behind me here I have a battery pack. It's a nickel metal hydride battery pack. It's out of a Toyota Prius. And the reason why I chose this one is because it's big and it's heavy, but it's a lot smaller than compared to a full electric vehicle battery. Electric vehicle battery, you're still doing the same type of procedures, but there's a lot more labor involved. So you're going to go ahead and you're going to perform the diagnostics using your scan tool, just like we always talked about in the past. So we're going to go ahead and look at our scan tool. We'd have it hooked up to the vehicle. We're going to see that, hey, it does actually need to be balanced. Now, once we went ahead and did that, now I know that some of these newer tools, like the Autel tools behind me and stuff, they have the ability to perform battery diagnostics as well. But I've told you, I've been a flat rate drivability tech pretty much my entire career. It's so much easier to use your scan tool than it is to take all the time to go ahead and hook up some of these other tools to figure out if you need to balance it or not. So the scan tool is real quick and easy. You just go ahead and use that. You would diagnose it saying, hey, I need to go ahead and perform a balance on this battery pack. Now, one of the main reasons why I chose a Toyota Prius too is because sometimes a battery may appear to be out of balance when it just has a pattern failure, or a silver or green bullet, as we've called them in the past. So on this Toyota Prius here, one of the common things that happens if the vehicle's never been updated is we have the little bus bars that connect all the modules, and the bus bars get all green and corroded. And we've talked about this and showed this on some of our previous videos, but this layer of corrosion can actually make your scan tool believe that the battery's out of balance. The performance is going to drop drastically. You might even set some battery related trouble codes as a result of that. So part of doing your battery service for your customer is going to involve not only performing diagnostics, but also a visual inspection on the vehicle. So once we went ahead and we took this battery pack out of the vehicle, we didn't need to do that on this particular vehicle. On a full EV, we would have to take it out of the vehicle, which, as we said before, is quite labor intensive, because now you're going to need a battery lifting table. You got to raise the vehicle up in the air. You got to safely disable the high voltage system. You got to lower that battery pack down to perform the service. Now, because you have to get to the modules on those. Now here, this particular Toyota Prius battery does have a little bit of corrosion in it. So again, I took it out, I took the top cover off, I did a visual inspection, and I said there is corrosion on there. So normally I would go ahead, before I went through the procedure of balancing the battery pack, I'd go ahead and I would take the bus bars off, the ones in the front and the back, and I would clean all that corrosion off. I'd clean it off with using a wire brush, whatever the case happens to be, and then it's going to appear to be very shiny silver. So I've got all the corrosion cleaned off of it using either a wire wheel, wire brush, whatever the case happens to be. I'd put it all back together. I'd hook my scan tool back up and I would test to make sure that the battery was still out of balance before I went any further. Now, battery thermal dynamics, which we've talked about quite a bit over the years that we've been making these videos, on a Toyota Prius or most hybrids, The battery thermodynamics is basically a blower motor. And we've already talked in great detail about how the inhaling vent gets all kinds of dust, and depending on the type of vehicle, Toyota Priuses are really bad. It's pretty much very easy if you have a young child that's sitting in a child seat in the back seat. You get French fries in that inhaling vent. You get everything that a kid has, right? So what you would want to do is you'd want to take the actual blower motor out of the vehicle. So now on some battery packs, it's going to be mounted to the side. We have another battery pack that's out of a Kia. It's actually mounted right to the side of it. But on a Toyota Prius, it's actually mounted up by the wheel well area. So I'm going to just go ahead and quickly remove these 3 screws here. And I'm going to show you, now this one's not that bad, but this is part of performing a battery service. It's not just balancing the high voltage battery pack. So you're actually providing a service and you're charging the customer for it. So you want to make sure that the battery thermodynamics and everything is good. So this one's not real bad, but you can kind of see that there's a lot of dust and debris and stuff right in this squirrel cage. So to service this, I would go ahead, I actually have a little toothbrush that I use. I'd go ahead and clean out all those little squirrel cage fins there. I'd take a compressed air blowgun and I'd blow that all off. If it's really bad, you might even want to use some simple green on it. Make this all clean. Also make sure that the squirrel cage housing is all cleaned out as well. So once you went ahead and did that, you would have to start with doing this procedure first if it has a blower motor, because you're going to need this fan in the process of balancing the battery. So just to save time on camera, I'm not going to put all the screws back in. I'll just put 1 screw in just to kind of hold it in place. And on the car, you would have some black ducts that come from where this mounts to the wheel well that connect to the actual opening here. And it would come down and it would blow air in the bottom of this battery pack. Now, as it blows the air in the bottom of the battery pack, that air is going to circulate up. It's going to help cool off the actual high voltage batteries as you go through it. Now, to perform the actual service. Now, before we started this, we'd want to at least look inside the bottom of this area down here just to make sure that that's not all full of dust and debris as well. Now, if it is, well, that's going to take a lot more work on our half, because now we're going to have to take all the individual modules out of the battery pack and we're going to have to clean that all off, with some simple green and a rag, whatever the case happens to be. We'd also want to go ahead, and this is something we talked about in previous videos as well. Another common problem that happens on the nickel metal hydride battery packs is the way how these modules are fastened to the bottom of the battery chassis here. It fastens down with 1 little Phillips head screw. It's got a little nut insert inside of it, and that little nut insert actually cracks the case. Now, there's a couple ways that we could go about checking this. Number 1, we could take every one of these battery modules out of the chassis here, and we can actually do a physical visual inspection on it, which is probably the most precise way. But I'll tell you from experience that if any one of those have cracked, some of the battery chemistry or the electrolyte, in this case nickel metal, starts to leak out and it turns the battery chassis like this yellow chalky color. So I went ahead and I looked at this. I know that none of these modules are actually faulty. None of them are actually cracked or anything. I've had this all apart. I've actually cleaned this all out just to save time on camera here. So then I'd put them all back inside the battery chassis here. I still have to go ahead and do the cleaning on the bus bars. I'll do that off camera as well. But I'm going to use a battery charger, discharger, and balancer kit that a company that's called Prolong actually made that says it's dedicated for the Toyota Prius battery packs. Now, I'm not going to lie, this was the first battery balancer setup that I ever purchased, because there's a million Toyota Priuses out there, and those are the ones that were coming into my shop on a regular basis. So I will tell you that this will also go ahead and charge and discharge A lithium battery, you can do it. It's going to take longer, but you can use this tool even for the lithium battery types as well. So to hook this tool up, it's going to come with a whole bunch of different accessories, right? I just have the ones that we need for this particular battery pack on the table here. I basically just go ahead and I start off with the charger discharger module. I hook up the one little cable in the back. I have it hooked up to the positive and negative contactors. So I have to be on the side of where the contactors, where all the battery modules go into the contactors, because the contactors aren't going to be closed in this scenario because we have no 12-volt source to actually close those contactors. So I go on the other side of the contactors. Now it also has this extra little box here. Now this box is actually made if it was capable of me performing this service while the battery was still in the vehicle. I could go ahead and unplug the blower motor and then plug this into the pigtail, and this little box basically controls the blower motor. Because remember, this is going to take a little bit of time. On a Toyota Prius like this, it'd probably take about an hour and a half to 2 hours on average to actually perform the balancing. We don't want the battery thermodynamics to get too high because then we could run into a stage of thermal runaway, something along those lines. So what I'm going to do is I'm going to just hook that little box directly up to, so I made a couple little jumper pigtails here, directly up to the positive and negative of the blower motor here. This way, this apparatus that we're using to charge and discharge this battery will turn this blower motor on, and I can circulate some air. I'm just going to kind of lay it in place over here because I don't have the ductwork. I'll just kind of lay it in place over here so it blows air so that it will actually cool off the battery. Now, one last thing before we get started with that. Part of the visual inspections, again, this is another silver bullet or a green bullet, whatever you want to call it. On a Toyota Prius battery pack, when it gets all corroded, if it's really extreme corrosion, a lot of times what will end up happening is the voltage drop is going to cause a lot of extra heat. And the heat, the battery bus bar module, and where the actual BMS module plugs into that harness from the battery bus bars, that gets all burnt. So you want to unplug that harness, do a visual inspection on both sides of it. The side that's going to the battery bus bars, plus the side that actually goes into the BMS module itself. So if you see that that's burnt, you have no choice but to go ahead and replace the BMS if this side is burnt, plus the actual BMS harness. Sometimes if you catch it early enough, you can get by with just replacing the module, the actual harness, instead of having to replace the module. So that again comes from experience of doing these, but again, we've covered this in previous videos as well. So to use this tool, basically what we would do, it's pretty simple. We would just give it some power here, and I'm going to plug these into my actual blower motor. And the tool, in essence, has a couple different selections for me. My discharge termination. So I could discharge this battery pack all the way down to only 17 volts. And from starting at approximately 220, that's a pretty deep discharge of the battery. Now, depending on how far out of balance this battery pack was, that might be something I want to do, because balancing a battery is in essence taking all the different modules here and the cells within the modules and dropping them all down to an equal state. And then we go ahead and we charge it back up. So I could go all the way down to 17 volts. I'm not going to do this for this video. What I'm going to do is I'm going to select the first one, which is 134 volts. So I'm in essence almost cutting the voltage down in half. This battery was not that far out of balance, so I can get by with the first rating. The middle rating is 84 volts. So depending on how far out of balance your scan tool told you that the battery pack was, is going to dictate how far you want to drain that battery pack all the way down. So at this point, what we would end up doing here is we've got the tool plugged in, we hit the power button here, and the tool's going to have two different LED displays. One is going to be a voltage display, one's going to be an amperage display. I've got the blower motor running because the box is doing its job here. So we're circulating some air through here. And I'm going to hit the first button, which is discharge termination of 134 volts here. So at this point, we're starting off with a voltage of 208 volts. And we're going to stop the balancing process, and we can actually start charging it once it goes down to 134 volts. So now we're at 207 volts, so you kind of see we started at 208, how quickly this has the capability of discharging the battery. Now, once we go ahead and we have this down, and let's just pretend like we fast forward, and this is now down all the way down to what our selection was of 134 volts. We're now down to 205 volts here, so it dropped it about 3 volts in this short amount of time. I would then go ahead and say, I'm done with this. It would shut itself off, right? And we're actually draining it at an amperage rate of about 1.2 amps on this setting. So I would go ahead and shut this off, and it would be time for me to go ahead and then go ahead and balance this battery pack back up. Now with the Prolong units, that's a separate unit. This is another little charger that we would have. That same cable on the top that goes over to the contactors would just plug right into the top of this one, and it's also going to control the blower motor. And then this one I would just go ahead and turn on, and it's just going to balance it back up. It's going to balance it back up until the battery is fully charged, which is about 220 volts or so. Now, you might be asking yourself and scratching your head at this point saying, hey, you said you could use it on an EV as well. Well, how can I use it on an EV with the lithium style battery pack? Because an EV battery pack is much higher in voltage. You know, 400 volts, 500 volts, 600 volts, 800 volts, whatever. Well, remember, when you're balancing an EV, even the tools that are made to balance an EV are incapable of balancing the entire battery pack at once. What they want you to do is have that battery pack lowered down using, you know, all the proper safety apparatuses such as the battery lifting table and all that other kind of stuff. Then they want you to take one module out of the battery pack. Now, some of the tools will allow you to do 2 modules at a time, but most of the time it's going to be one module. The problem with it is, in order to get that module, so I've got this module all the way apart on this battery pack over here already, I have to be able to separate to get to the actual cells, because this one, all the ones that are made for lithium, want you to balance at the cell level. So that's a big concern for us technicians, because realistically, in order to do this job, if there's 16 modules, let's say, and let's say we're really batting 1,000 here, and we can actually take the modules apart to get to the actual cells, like I have displayed set up over here, because a lot of times on the American cars, these don't come apart. So in order to get to the cells, I would literally have to cut these apart. And once I cut the chassis of the actual module apart to get to the cell voltages here, well, now I can't reuse it. But fortunately, this particular one that we're using as an example will allow me to take it apart. It's not easy to do, but I went ahead and took this apart just to save time on camera here. Now I can actually do this service on here. So once I went ahead and did that, that particular battery pack has about 300 volts of operating range. So obviously it's much higher than this one. So you would say that, hey, this charger is going to want to shut itself off at approximately 230 volts or so. So how would I ever balance that battery pack? Well, I would have to do it module by module, because that's the way we're supposed to do it with lithium style batteries. And again, I would still want to have that cooling fan activated on that one so that we're circulating air through there. This is a hybrid battery pack as well out of IKEA. Just so that everybody understands, in order to do this, we do need to have the actual high voltage service plugs in place when we're doing an entire battery pack like this. So I know I haven't had my gloves on. They're in the back over here just to prove to you I did wear my gloves when I was setting all this up. But once it was set up, you notice I just made sure I wasn't touching anything that could harm me here. So, and the high voltage disconnect is in place on this Toyota. On the back side, you can't really see it on the camera. Now, before I turn the charger discharger balancer on, so the CDT 100, that's already hooked up to that module over here, I want to talk about the BCE, which is the battery cell equalizer, because there's a difference between a balancer and a charger discharger tester. Now remember, anytime I'm draining the battery and then charging it back up, technically in theory, I am balancing the battery pack. Now the difference is, with the battery balancer, I have no choice but to take the battery all apart, take the modules apart, and hook up all the extra wires. Technically, with the charger discharger balancer, which is the one that's on the cart over here, I do have a choice. So I could actually go ahead and hook it up to the entire battery pack, and although I would not be balancing the cells, I would be balancing the modules with this tool if I hooked it up that way. So in order to use this tool, and this tool actually can charge or discharge at a rate of 240 amps, and it can charge at a rate of 100 amps. So it's much quicker as well than using just the balancer, which has a much smaller range of operation. Because again, it is made to just do one module at a time. No more than one module at a time. So, and in those cases, you know, it's got 24 wires that I could hook up to. So if there's 24 cells within that module, I'm able to balance it. If there's more than 24 cells, then I would have to go ahead and balance the 24 cells and then hook up the wires to the rest of them, and it would take a lot longer to actually balance that battery pack. So what I would do, since this is already all hooked up, is I would power up the CDT unit over here, and to use the balancer itself, I would do it the exact same way, right? I would hook up those wires just like how I have it hooked up to that battery module right now. And it's got two on buttons on it. So the first one is just turning the AC power on. So once the Autel screen goes away, it's going to come up and it's going to give me some little squares, and we've shot a whole video on this in the past. But those 4 squares that are going to come up are going to ask me, you know, basically what am I trying to do here? Am I trying to charge a battery? Am I trying to discharge a battery pack? Am I looking at previous records? Or the other selection would be settings, right? So we can't charge it until we actually discharge it. So if I went and hit the discharge button, I would have to fill out the menu there. And we've talked about this in great detail, and this is one of the advantages of marrying that tool to the Autel scan tool, because that's going to force me to set up about, I want to say 10 or 12 different settings on this tool, which they're already all set up, so I don't have to do that. I didn't want to waste the camera time showing you how to set it up again, because we've already done it in other videos. But if you don't happen to have the Autel scan tool and you just happen to have that, it does give you an option that you can go ahead and use just this setup menu. Now the second button over here, once I went ahead and hooked up all these wires, I'd have to hit the DC on button. Now the DC on button, in essence, what it's doing is it's turning on this extra little string module over here and all these extra little wires. So at this point, I'm going to go ahead and I'm going to say save. And now, I said before, if I wanted to, I could perform battery diagnostics on that tool, but it's very limited battery diagnostics. I would literally have to do this for every single module. And on this particular battery pack, there's a total of 6 modules inside here. I'm just doing 1 right now, so I'd have to do this over and over and over again. That's another huge advantage to using the scan tool, as we said at the beginning of this video, because I could diagnose the entire battery pack with the scan tool all at once instead of having to take the battery out, take it all apart, and hook this up to each and every individual module. So at this point, once I had everything hooked up the way I thought it should be, I'd have to hook up these last two wires, the two big heavy duty wires, to the positive and negative of this module. Then I would hit the start button. That start button will go ahead and allow me to start, since we selected discharge, to discharge that particular battery module. Now inside that module there's 8 cells, so it's discharging all 8 of those cells simultaneously. And again, depending on how I program the setup is going to dictate how fast they're going to discharge. Now one thing I want to throw out there as a word of caution is we also have these extra wires on our string module, and we've said this in the other videos. These are our temperature wires. So I want to make sure before I were to start a process that I have these strategically placed around the battery cells. Here's the reason being. The tool is assuming you've set it up correctly. So if that one module fully charges about 36 volts on average for this particular battery pack, if I told it that it was, let's say, 136 volts, it's going to try to charge it to 136 volts. It will not be able to shut itself off if there's no safety built into it. That's what the thermistor wires are for. So this way, if it ever started to get too warm, now, because I have the thermistor wires strategically placed around the module that I'm trying to charge here, it would see that the temperature is getting too high. I've got it set so anytime the temperature got up greater than 140 degrees Fahrenheit, it would want to shut that tool off. Now, if it gets real too high, it's going to shut it off. It's not going to turn it back on. If it gets up to 142, well, it would momentarily pause it, and it would wait for that temperature to come back down, and then it would self-start back up. But if it ever got, 200 degrees Fahrenheit or something like that, it's not going to restart. There's a lot of safeties, as we said before. I got the emergency stop button over here. So there's other safeties built into it. But again, it's vitally important that you use the battery identification number, the BIN as we call it in the industry, to get all the information about the battery that you're balancing, because that is how you're going to perform the setup menus. Now this Prolong unit, it was made pretty much just for the Toyota vehicles here. So there is no setup menu because when it first came out, it was only made for this. So it was already programmed into it. There was no selections of me having to go in and type different information in. Now, because that battery module is only 36 volts, I could hook this tool up and I could use it to balance a high voltage battery of a lithium style. Technically, I could go all the way up to 220 volts of that. So if let's just say they were 30 volts apiece, well now, so if I had 4 of them, that would be 120 volts, right? So you could do the math in your head and you could say that's how many different modules I could have hooked up, and this would still work. Now this discharges and charges at a much lower amperage though. It's only 110. It's not a choice of either 110 or 220. So it will take longer, but it will actually work on a lithium style battery. So one last tool, and we've did a video on this in the past as well, is the actual battery enclosure tester. And I want to pull that out to everybody's attention, because part of doing the battery service, after you went ahead, did your visual inspection, cleaned any corrosion, go ahead and make sure the blower motor's properly working, make sure that it's all clean from debris and everything. But to do all this, you had to take the cover off the battery pack. Now on a hybrid, there is no enclosure, right? But on an EV, since it's on the outside of the vehicle, once you put that battery top back on, by law, you have to use a battery enclosure tester to actually make sure that it's got a nice tight seal. Because again, we don't want any kind of salt water or anything getting inside that battery pack that could, in essence, start a fire. So I wanted to just kind of show people what all was actually involved in doing a battery service for customers, because I know there's a lot of misconceptions out there where people think that, hey, all I got to do is take and hook up a couple wires and hook it up to the battery pack, and I'm going to balance a battery and I'm going to make a whole bunch of money. Well, that's not necessarily the case. There's a lot more to it than what you might have thought or heard about on the internet to do the job correctly. And you know, the customers will pay. They'll pay for this service because it prolongs the life of the battery. It's the modern day tune-up, as we've said on our other videos. Prolongs the life of the battery, gives the battery better performance, and nobody wants to get stuck with the high battery replacement bill. So they're willing to pay for your service and your time, but if you're going to charge them for it, make sure you're doing a complete service. And that involves everything from visual inspections, taking the battery out, going through the time it's going to take to actually balance, charge, discharge, and balance the individual modules or cells, depending on the type of tool that you're actually using here. So I hope this was helpful. One last thing I'm just going to throw out there, because every time I have something on a table and I don't talk about it, usually I get comments later on. I bought the more expensive version of the Prolong kit here. Technically, I could have bought the cheaper version of it, and I could drain the battery pack with just these light bulbs. So again, I'd have this module, and I'd take this cable that goes to the top of the charger discharger, and I'd plug it into here. I turn my little voltmeter on. This takes a long time to discharge a battery pack, because basically the only thing I'm using is the amperage load of these light bulbs to drain this battery pack down. So I'm not telling you not to buy this setup. It is cheaper to buy it this way. I went ahead and bought this as a separate add-on. This by itself isn't very expensive at all, but I did it just so I can show people when we do the hands-on training classes the differences between these. So hopefully you guys found this interesting. Hopefully this answers a lot of questions that you guys may have and some of the stuff that you guys have been seeing on the internet. And now hopefully you have a better understanding of how to perform these services. Thanks for watching. So we should be done. Yeah, just hit the bottom button, the one underneath it.
Oh, okay.